Pasal takut pula. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farif Fauzal bin Haris. I am the leader of the group 14 and my group members consist of Muhammad Danish Ishraf, Muhammad Faiz Arshad and Muhammad Farhan. Today, my team want to present the leader of the air pollution monitor system. Next, I will start with an introduction. When air get mixed with harmful gases and substances in calling air pollution, the major pollution of the air are gases such as ammonia, carbon monoxide, sulfur dioxide, nitrogen oxides, methane. The source of the pollution are the interaction misses, hazardous emission from the venison burning of the fossil fuel. Pollution air can cause severe health effects such as the heart disease, cancer, reputation infection. This project is aimed to deliver an IoT-based application to deal with air pollution, which they have the of the concern sensor such as MQ7 variance air perimeter are sent and transmitted. ESP32 developed but plays important role in the project. The protector connect with the Wi-Fi employ all the air perimeter to serialize serve. That's all for me. Next, I will to pass our group presenters to next presenter, Fai Asyad.
Okay, thank you, Muhammad Faris Fauzan. My name is Muhammad Faris Arshad, and I will continue the presentation to talk about the requirement in this project. So basically, this project need some requirement to make it work. So by distinguish the difference between the existing system and the proposed system, we can see the pros and cons of this project. So the existing system now is to collect the parameter many mechanical devices are used. These devices are heavy and not economical to install at many places. So periodical collection of data is very difficult and it still use manual intervention to collect and feeding data to central servers. But the proposed system that this project proposed, since it's IoT-based product, all functional units are connected in a network. All things such as sensor-based station, centralized server work together by means of communication over network. Data collected from sensor gets uploaded to cloud servers instantly. For authorized such as pollution control board, data is easily available, and the most important of all is can easily be draw and take action. Okay, next. So next is the requirement that needed to make this project. Some example of hardware requirement including processor which is i3 or higher, RAM 2 gig or higher, hard disk which we need 500 gig, MQ7 sensor, ESP3 to 32 kit, breadboard and jumper wire. And the software requirement including some website such as Bootstrap framework, and the programming language that we use in this project is C++ and Java, and the operating system can from Windows 7 or any compatible system. We also use IDE Arduino and Android 2.3.2. And that's all from me for now, and then the presentation will be continued with our next presenter, Danish Ikram.
Thank you, Faik. Now I will continue my part, which is the methodology. Firstly, the flowchart. At first, we're going to start the program And the first component, which is the MQ1235, will detect the pollution inside the air. And then the data from the MQ135 will send to the Node MCU and will be processed inside the library. The next one, next, no, not MCU, will establish the connection to the server using Wi-Fi. Then the data will be uploaded to the server. After data are uploaded to the server, graph and data table will be created. After that, the data will be delivered to the OLED display, and the OLED display will display the output in a numerical form. For the next part is the source code. The source code or program for making a IoT-based equality index monitoring with ESP8266 and MQ135 is given below. In the below code, you need to make changes to Wi-Fi SSID and password. Also make sure to make changes to API key from ThingsPeak. The code also requires MQ135 library for compilation. So download the library from the following link below. As you can see, this is the code that I use in this code in this program for making the air quality index monitoring system. And this is the following code that I use. And this is the last one. For the next part, still in the methodology, the schematic diagram. Firstly, the interface MQ135, a quality sensor with a Node MCU, ESP8266 board, and 0.96 12C OLED display. Assemble the circuit in the breadboard. First, connect the MQ135 analog input to A0 of Node MCU. Then connect its AVCC and ground to Node MCU VIN and ground respectively. Similarly, 0.96 OLED display is an 12C module. So connect SDA and SCL pin to Node MCU D2 and D1 pins. Connect its VCC to 3.3 ground to ground. That's all from me. Now I will pass to Faik.
Thank you, Danish. So here it show the process or progress of our system or our project. So the first is the program is constructed as a way to calculate our air pollution. Basically, it means that it's like a brain in our system. So next is the circuit was constructed as an air pollution monitoring system. So the how to what how to see how if it would incense were used as a substitute for polluted air. So after the it detect the polluted air, the output will be shown on the display, and using Wi-Fi connection, the output data from the circuit was sent to the website, and from the data received, a graph was constructed, and that all that I will show. So I will give the baton to Muhammad Farhan.
Thank you, Pak Arshad. Now, I would like to continue our group presentation about result. As you can see, once the code is uploaded, then you can open serial monitor. The Nodem CU will first start connected to the Wi-Fi network. All the happening can be observed on serial monitor. For example, on the show the white one, the white picture one, you can see the data that has been collected, such as the air quality, which is 14.4 ppm. Next, once you connected to a Wi-Fi network, the sensor will read the value and the value will display on the OLED screen. Next slide. Similarly, you can see the online data of air quality index on ThinkSpeed server. Just go to the ThinkSpeed private view and check the data being uploaded after the interval of 50 seconds. Next, I would like to talk about discussion. Okay, from this project, students managed to create Arduino IoT Cloud by using ThinkSpeed website. Students managed to create an air pollution monitoring system. Firstly, component MQ135 will detect the pollution inside the air. MQ135 will send the input to the Node MCU for it served by using Wi-Fi. Sorry, my mistake. Firstly, component MQ135 will detect the pollution inside the air. Next, MQ135 will send the input to the Node MCU for it be processed inside the library. Thus, Node MCU will establish connection to ThinkSpeed server by using Wi-Fi. Next, the data are already being processed will be uploaded to the server. The data will be processed again and uploaded to the ThinkSpeed to create graph and data table. Lastly, the data will be delivered to OLED display and the output will be displayed on the display in numerical form. Lastly but not least, I will talk about the conclusion. Environmental parameter monitoring, particularly in relation to air, is critical for ensuring a healthy environment for living creatures. Due to the air pollution, we have witnessed a variety threat in the world. There are a variety of factors that contribute to air pollution, but understanding its level in different areas is in determining preventative strategy. The proposed application is based on IoT principle, which data from the sensor being processed by the processor ESP32 and uploaded to the database where it is analyzed and displayed to the user, and the user being able to retrieve the information on their via phone or web server and take the appropriate action to avoid pollution. That's all from me. Thank you. Yes, I will pass our group presentation to the last presenter, Faris Fauzan.
Thank you, Farham. Now I want to show the link YouTube about the reframe our project. This project we use the video reference this link. Lastly, that's all the us. Thank you.